Hey everyone, this is Matt. We'll learn everything about design. And in today's video, we're going to talk a little bit more about what's new in Fusion for May 2024, specifically with assemblies. Now, this is something I did not cover in yesterday's video because honestly, it's confusing, it's a bit cumbersome, and it's not really clear on use cases on where it's going to make sense. But in this video, I'm going to try to answer some of those questions. We're going to look at some examples and hopefully make it a little bit clearer. So what I'm talking about specifically is ground to parent. Now, this is something that showed up in yesterday's update. And if you happen to be creating a new assembly, you create a new component, that new component is going to have a little icon underneath it. It's got a sort of a boat anchor icon. Anytime we make new components, by default, they're going to have this ground to parent. If you hover over them, it'll tell you that it's ground to component one. In this case, component one is ground to the top level of our assembly. This is an option that you can turn off. If you go to your user preferences, go to the design assembly section, you can turn off the first component ground to parent. And when we do that, if we make new components, they're no longer going to have that ground to parent option, but we can right click and we can turn that on whenever we want. So why is this important? Well, there are a few sort of implications on why this might be beneficial, why we would want to do this over, say, something like a rigid group or pinning it to the top level. So the reason for that is there's no feature in the timeline. It doesn't add or remove anything every time we decide to pin or unpin or unground something. So that's a benefit right there. However, what I found is that it's actually a little bit harder to go back through and figure out if your assembly is over or under constrained. I think it's a bit easier just to use the traditional rigid group and joints, but that's not to say that there aren't going to be applications for this. So let's go ahead and take a look at a couple of examples to make sure we understand what's going on. First, if you have no idea what I'm talking about, here's a simple example with a message board. The board itself is a component inside of this design, and each of the notes are individual components underneath it. Now, why is this important? It's because we need to understand that at the very top level of our design, by default, we have a component. Now, the board itself is a component that contains sub-components, which are these notes. If I just move the board, all the notes stay with the board. By default, they want to be with it, and we don't need to have them pinned or ground or anything else. However, if I go to move the notes, they're free to move about. Each note contains its own coordinate system, and that origin, XYZ0, is going to move around with that note. That's true for all of the notes in this design. Each one has their own origin and they're free to move about. If I revert them back, they go back to wherever they were in the design, but it is important to note that they do have their own coordinate system, and that's why Fusion needs to track the component's origin, either by grounding to parent, by pinning, or by some sort of joint. So how do we get around this traditionally? Well, if we want the board to be fixed in place, we could right click and we can pin it. Pinning it, it's going to add a feature in the timeline. And if we want to undo that and we unpin it, it's going to add another feature in the timeline. So we can either go back and delete these, or we can simply continue to pin and unpin when we want to move it around. That's not a real elegant solution, but it's what we've had to work with. The other thing that we could do is we could create a rigid joint between it and the top level of our design. Now this can be done with an as-built joint because it's in the correct location. Rigid, and we're going to select the board and the top level, and those will be the two components selected, and we'll say OK. So now there's a joint. We can't move it around. It's fixed in space. However, each of the notes can still move around freely. Because of that, we would need to create either a rigid group or pin the notes in their locations. Now, a rigid group is great because all we need to do is select the board, go to Assemble, and we need to select rigid group. If we include all the children components and say OK, all of the notes are now fixed relative to the coordinate system of our board. Now, the problem with this is it's kind of a pain to undo. If we decide that we want to move some of those notes around, we either need to go back and temporarily suppress the rigid group, or we potentially need to move the bodies inside of those components. So by using something like move copy, I can move the body around. But notice that the body is no longer in the same location relative to its own coordinate system. So there are not really great solutions to either of these problems. So this is a situation where ground to parent might be a good option. However, it's a little bit more complicated than that. And again, this is why I kind of left it out of the What's New video, because there are so many little nuances. If I select this note and I right click and I select ground to parent, it tells me that it may move to its initial position. Now, ground to parent is going to override the move, any move features that we had in the timeline, and it's going to put it back to its original origin. This is one reason why ground to parent is not ideal in every situation. If I select OK, ground to parent, it's going to snap the origin of that Note 1 component to the origin of the parent component or board. Now, if I instead take this note, right click and pin it, I'm going to get the same thing. It's going to be pinned in that location. However, it doesn't care where it is. It's free to move about before that ever happened, and it's not going to undo any features that we had in our timeline. Now, part of this comes back to the fact that if we use a move feature, so let's go ahead and just move this component. I'm going to just put it off the board, capture its position. When we're doing this to a component, it is able to capture its position, but it's not able to understand how far it moved. We can undo that and we can go back to a previous location. If instead we went to this body and we used move and sort of move the body off, and this is independent of its coordinate system, that move feature doesn't remain linked to the value. It doesn't know that we moved it 50 millimeters or 100 millimeters. And this is the problem because when we go to use ground to parent, it's going to snap it back to those locations, which means it's going to take the origin and it's going to move it back to its original position, not where it is in our assembly. So because of this, it's important to understand that when you're starting a new assembly and you're beginning with a new component, ground to parent is fine because there is no geometry in place. If you happen to be working inside of a component and you move bodies around, for example, it gets a bit more complicated because ground to parent then has to go back and untangle some wires, and your components may not be where you want them to be. So why is this important? Well, in reality, it's important because we need to understand whether or not we want to use a rigid group or if we want to use something like ground to parent. Here's two examples. This is going to contain 4 of these little eyelets that nest together. Each of them is an independent component, and they are grounded together using a rigid group. Now, this means that they're free to move about inside of the parent component, but the parent component is grounded or pinned at the top level. So if I unpin this, I can move everything around. If I pin it again, then everything is going to be fixed in space. Now, again, you can see the problem here is we've got all these pin, unpin features in the timeline. So in reality, what you would want to do is go back and suppress or delete the original pin. That way we don't have to deal with adding and removing a ton of these features to get back to that level. Now, this is a good example where ground to parent is actually a good solution. Because each of these components is in the correct location, ground to parent is a good solution. If I want all of them to move, all I need to do is unground the top level component from the parent. I can capture its new position, and then I can go back and ground to parent. Now, once again, the problem is it's going to snap back to that original location. So if that's what we needed to do, we need to unground, move it to its new location, capture its position, and then pin it. So again, not a great, wonderful solution, but let's take a look at 2 more examples here. Now, this is a rotary engine assembly. This is part of our Absolute Beginner's Guide to Assemblies on our Learn Everything About Design website. So if you want to learn how this engine was put together, as well as a couple of other examples, definitely check that course out. But inside of this, we've got a rotating assembly for a radial airplane engine. So as everything moves around inside this engine, there's obviously a lot going on. There are many different joints. There are some components that are rigid, things that are bolted together, like the cylinder heads, the cylinders, and the engine case. This is an example where I would still go back and use rigid groups between those assembly components, and I would pin one top-level component, let's say the engine case in this, and the engine case, specifically the back of the engine case, is pinned and everything else is grounded to it. This is one good way that we can manage the assembly motion as well as the fixed components in an assembly. To take a look at this with the ground to parent option, we still have a lot of joints. We still are required to have some rigid groups. For example, the front and rear sections of the crankshaft. These are 2 individual pieces and they need to be a rigid group together, either as an as-built joint or potentially just as a rigid group. That's not something where we can use ground to parent. However, the cylinders, the cylinder head, the engine case, those are things that can be grounded to parent. But a word of caution, in this specific example, it took a lot more investigative work to figure out the mechanical motion because I was having trouble with some things being locked and some things not moving, when in reality, there was no visible way to see whether or not it was fixed relative to something else. There was no rigid group, there was no assembly joint that was mechanically locking it, and there was no ground to parent inside of the browser. So in this case, it was a lot more difficult for me to manage the assembly going back through when I was using the ground to parent option, whereas using a rigid group that contained pretty much all the static items in the assembly, and keeping in mind that there was a rigid group between the front and rear portions of the crank, this was much easier for me to troubleshoot because I could temporarily suppress those, I could animate the joints, and I could figure out at which point in the timeline that things kind of went awry. So keep that in mind. This is a big, big topic, and there are a lot of other little nuances that have to go along with this. Things like when you insert components into an assembly, and again, insert component, this is new. When you insert a ground to parent subassembly inside of a new assembly, that ground to parent is going to bring in those grounded options. And in order for us to turn those off, we need to do an edit in place. Then we can right click and unground from parent. We can finish the edit in place, and that will allow some of them to move independently. Now, this is true. The behavior is still the same as if you were inserting a traditional component, for example, using rigid groups. The behavior is going to be the same. We still need to use the edit in place option if we don't break the link to be able to go into our joints and edit our joint so that way we have one of these components that is not included. And then we need to finish edit in place, and then it's going to be free to move about. So the management when you insert an external component into an assembly is going to behave very similar, but the nuances of what happens with things like move body features inside of components and the fact that it's going to snap back to some original locations, that to me means that I am going to turn off the ground to parent option inside of my user preferences, and I'm likely going to still continue to use my traditional method of using rigid groups inside of joints, just because for me, mechanically, it's a little bit easier for me to diagnose an assembly, especially when problems arise. And the fact that currently using the ground to parent option doesn't allow us to have things like move body features inside of a component. That to me is a potential problem. And if I decide to make changes to a component downstream, I don't really want to deal with the fallout of what happens if I have any of those features earlier on. So I think that it has some good use cases. There are some pros because it doesn't put a feature in the timeline, for example, but I don't think it's quite there to where I'll be implementing it for all my assemblies. If you have any questions on this topic, if there's something I didn't quite cover, please leave a comment below and let me know. As always, thanks for watching, and we'll see you in the next one.